Now this question is a graph question using modulus or absolute value. Okay, the graph of a function such that from -4 to +2 in the x inclusive maps to their respective real values, where f of x is 1/10 of x into x minus 1 times x plus 3 all squared. So this is a quartic, guys. It's shown below. So in part A we have to draw on the same set of axes the graph of minus absolute value or modulus of f of x. Part B, state the range of the function which has the rule of y equals modulus of f of x, where x goes from -4 to +2. So that is the range of the absolute value function, the modulus of f of x, yeah? And part C, we have to draw on the same set of axes the graph of f of modulus of x. Now that's considerably harder for a lot of students, but it's a piece of cake, guys, when I show you what to do. Now, okay, off you go. Pause the video. Right, you're back. Alright. Part A. Now, before I do that, I think this is probably a reasonable standard of question, very close to what you'd get in an exam 1 situation, alright? So we should be able to do it no problem. Now, draw on the same set of axes the graph of minus mod f of x, okay? Here it comes. Have you done it? Alright, well this is what I think. Now, what did I do? How did I do that? Well, firstly I found the modulus of f of x, which reflects everything below the x-axis to above it, and then I reflected the whole lot of it to below the x-axis to get minus modulus of f of x, okay? Do you agree with me? I think it's pretty straightforward. If you do the modulus of this blue line here, it'll go like this. Watch my froggy finger. It goes like that, then it goes like that, there, and then up, and then you just reflect the whole thing about the x-axis to get what they're asking, alright? Yes, no problem. Now for part B, we've got to determine the range of the function, which has the rule of y equals modulus of f of x, where x goes from -4 to +2. Now just having a look at the graph, guys, I think we've got to analyse the value of modulus of f of x here, where x is -4, and here, where x is 2, and I think then we can work out the range very easily from that, just confirming that they give us the highest values, and then to choose the highest value from those two values. So let's do it. F of -4, well, modulus of f of -4 is the same as f of -4 because they're actually in the positive y region anyway, and that gets us +2. Modulus of f of 2 is the same as f of 2 because that's also a positive value of y, and that gets us +5. So this is the higher value, this is the one we want, but for the range, guys, the range will be, having a look at the graph, not 2 to 5, but from 0 to 5. Do you see that? You have to be very, very careful with that, okay? Because the modulus does go from 0 upwards to this maximum value here at the end point where x was +2 and y was 5. Alright, now part C. Now that's a pretty curly one. That is f of mod x. What do you think? Have you done it? Well, fasten your seatbelts, here it comes. F of mod x reflects the part of the graph which is already to the right of the y-axis about the y-axis. So the bit to the left of the y-axis, which is over here, just basically gets annihilated. And this bit over here, this bit there, gets reflected about the y-axis. So you get that. That is the result. I know, but that is the result. You've got to get used to that. You have to know that. That's what f of mod x does. And very briefly, the reason that it does it is because when you have mod x, whether x is negative or positive, x takes the positive value, and therefore the value of y, which you get from applying the rule, is exactly the same for a negative x as it is for a positive x, because the negative x's are transformed into positive x's by the virtue of that modulus. Okay, so -3 becomes +3, and when you have -3, therefore, you get f of +3, which is exactly the same as the f value which you'd get over here, or wherever 3 is on the graph. That's how it works, guys, and you have to know that, alright? Alright, I think that's all. So, I hope you enjoyed that, and we'll see you soon.